Welcome to Unit 3 Chemistry, Lesson 3, Chemical Formulas, Mastery Session with Mrs. Byrne. Lesson 3 is all about chemical formulas. A chemical formula is a combination of symbols and numbers that show how many atoms of each kind of element are in a molecule of a particular compound. So, let's look at H2O. What do these letters and numbers mean? We know that H2O represents a molecule of water. We've seen this before, that's not new to us. But what does that H, that 2, and that O mean? The H represents hydrogen. The 2 tells us there are 2 hydrogen atoms. And the single O tells us there's only 1 oxygen atom. Even though there's not a 1 after that O, that's what that means. If there was a number after it, a 2, a 3, a 6, a 12, that would tell us there would be that certain number of the atoms per molecule. Okay? So when there's nothing, that means there's only 1. We're going to discuss 2 different kinds. First is ionic compounds. So let's look at ionic compound formulas. Formulas tell us how many atoms are in a molecule of a compound. So when we looked at that H2O, we knew by it saying H2, there are 2 atoms, 2 hydrogen atoms in that one molecule of water. But how do we know how many atoms there should be? Alright, so if we are given 2 atoms, and we want to combine them, we need to know how to combine them and how many atoms there should be when they combine. So all ionic, when dealing with ionic compounds, all of them are electrically balanced or have a neutral charge, a charge of 0. Do you remember in previous lessons when we looked at sodium chloride? We looked specifically at the charges of sodium and chlorine within a molecule of sodium chloride. What charge did they have? Sodium had a positive charge, chlorine had a negative charge. When we combine sodium and chlorine, that gives us sodium chloride. Is it an electrically balanced compound? Yes. Yes, it is an electrically balanced compound. Let's look a little bit closer at that. So, sodium chloride. We know that sodium has a positive charge. We know that chlorine has a negative charge. So when we are building this chemical formula, we would build it like this. Na plus a Cl minus gives us NaCl. There's no numbers here. There are no charges. It is electrically neutral. It is an ionic compound. Sodium plus chlorine gives us sodium chloride. Let's look at another one. You've seen this one in your online lesson. Calcium fluoride. Calcium is Ca2+. Fluorine is F-. Now in the picture they've given you that one just as a reminder that there's only 1 fluorine atom. But remember, in general applications you do not put that 1 there. When you combine the calcium, Ca2+, plus that negatively charged fluorine atom, so it would be calcium plus fluorine, gives us calcium fluoride. But what does that look like, okay? CaF2. Because we need it to be balanced. It is an ionic compound, so we need it to be balanced. We need it to be electrically neutral. That's why that F has the 2 after it. Let's look at our next type of compound. Covalent compound formulas. So we did ionic, now we're going to do covalent. For a covalent compound, the chemical formula shows how many atoms of each kind join together to form the molecules of the compound. Shows together to form the molecules of the compound, a molecular formula. So, no positive or negative charges are needed when looking at a molecular formula. It's basically just a picture of those atoms joining together to form that molecule. Instead of charges, we use prefixes. Here's our prefix table. 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, and 9 nona. I hope I said that right. We have all heard of carbon dioxide. It's kind of like that water molecule. We've all heard of it. We've all seen it somewhere. It's something that we know. So let's build on that we know. What is the molecular formula for carbon dioxide? We know that it is 1 carbon atom and 2 oxygen atoms because you have that di there, okay? That's how we know that it's 2 oxygen atoms. So in the previous ones when we're looking at those chemical formulas, we knew it was a 2 by that designated number. There was a 2 after it. When we're dealing with the prefixes, we know that it's a 2 because of the prefix that's added onto that word. Alright, there's nothing on carbon, so we know that it's just 1 carbon atom, and it's 2 because of the di in front of the oxide. Let's try some molecular formulas. So this one, the first one I've given for you, sulfur trioxide. 1 sulfur atom and 1, 2, 3 oxygen atoms. When we go back to that prefix table, we see that 3 is a tri. Sulfur trioxide. Dinitrogen trioxide. So the first 2 we've done have had no prefix on that first word. This one has a prefix on the first word. It has a prefix on the second word. Dinitrogen trioxide. Let's go back to that prefix table. Di means 2. So we know that there should be a 2 here. 2 nitrogen. Trioxide. Tri is 3. So there should be 3 oxygen. Let's see. 1, 2, 3 oxygen, 1, 2 nitrogen. Yep, we did that one right. So that is how you do molecular formulas. Structural formulas. So structural formulas are used to represent a covalent molecule. We talked about that. Back to the covalent. Let's look at some photos, some structural formulas, and see if we can figure out their chemical formulas. Alright, so this was the prefixes. We checked it with the pictures. Now we're just going to go straight from the pictures and see if we can come up with these. Start with carbon atoms. When you're looking at those pictures and you're trying to figure out the structural formula of them, you want to start with carbon atoms, move on to hydrogen atoms, and then do your oxygen atoms. The first one we're going to look at is butanol. So what is the chemical formula for butanol? We all know what that is, right? Here's our structural formula. This is how these atoms bind with each other, okay? You can see there are carbon atoms, hydrogen atoms, and oxygen atoms. What was it that we said we had to start with? What goes first? Okay, that's right, yep. Carbon atoms. So let's count the carbon atoms. 1, 2, 3, 4. So we know that there are 4 carbon atoms. So that goes down first. Then we want to count the hydrogen atoms. Start from the top, work your way around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's represented by an H10. And then lastly, we want to count those oxygen atoms. As you can see, there is only one oxygen atom. So would we put O1 or would we just leave it as O? We would just leave it as O. So the chemical formula based on this structural formula is C4H10O for butanol. Let's take a look at another one. Glucose. We've all heard of the word glucose before, but have you ever seen a structural formula for glucose? Well, here it is, all right? So this one's a little more complex, but if we use this, that's what I do. I start at the top, work my way around just like a clock, so I know I don't skip any. So what is the chemical formula for glucose? Let's count first our carbon atoms, because you always do the carbon atoms first. 1, 2, 3, 4, 5, 6. So there are 6 carbon atoms. Up next is hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 hydrogen atoms. I'm going to double check myself. It seems like I might have missed one. So I'm going to double check my counting. And then how many oxygen atoms are there? 1, 2, 3, 4, 5, 6. 6 oxygen atoms. So we know we start with carbon, we know we start with second is hydrogen, and we know we end with oxygen. So the chemical formula for glucose is C6H12O6. Based on that structural formula, we were able to get the chemical formula. Writing chemical formulas. So now that we know how to do that, we should be able to write out a chemical formula, a chemical equation. So a chemical equation shows a relationship between the substances on the left-hand side of the equation and substances on the right-hand side of the equation. So let's fill in those blanks. The substances on the left-hand side of the equation are called the reactants. And the substances on the right-hand side of the equation are called the products. So we're building a good system here. Let's take a look at some examples of chemical formulas. So, carbon dioxide plus water gives us carbonic acid. The reactants in this chemical equation, CO2 plus H2O, those are the reactants, air and water, and the product is carbonic acid. The second equation, CaCO3, which is just limestone, plus H2CO3, which we've already seen that is carbonic acid, gives us calcium bicarbonate. Okay? Limestone and carbonic acid are the reactants. The product is calcium bicarbonate. A polymer is a covalently bonded molecule consisting of repeating chemical units. So these units can form very long chains. Each of the repeating units is called a monomer. So the chemical formula of the monomer is simply repeated many times over in the polymer. When we're talking about a polymer and a monomer, it's easy if you think of the root meaning of these words. So mono means single or alone, and poly means much or many. So a polymer is just many of one. For example, here is a monomer. It's just a basic representation. There's They're not giving you letters, numbers, just so you can get the idea. When the polymerization happens of that monomer, you then have a polymer. For example, take a look at ethylene. All right, so you can see in each one of these individual, let me circle that for you so you can see that. So here is one. All right, that is one, and it's represented 4 different times, okay? Polymerization happens, and we get polyethylene. This is the same thing as this. It's just repeating itself, all right? They're all hooked together. That is the difference. It's a long chain of this unit. And remember, a polymer is a covalently bonded molecule, all right, consisting of repeating chemical units. So it's the same thing repeated over and over. All right, now that we have finished the mastery session, Unit 3, Lesson 3, take your test. If you do not pass your test after this mastery session, please call me or K-mail me, and let's set up a one-on-one session to go over this content together. Good luck.